welcome back to our course on product engineering and design thinking. Today we would be discussing the complexity of a product design and development, and we are in the module 7 and the lecture number is 32. The complexity mitigation of multidisciplinary system. When we are saying multidisciplinary system, practically from the mechanical engineering perspective, if we see, then with mechanical engineering, naturally for a complex product, whatever we see nowadays, starting from the cars to refrigerators to air conditioners, most of the products are becoming mechatronic in nature. That means, instead of pure mechanicals, the electronic involvement is coming in, control system involvement is coming in, and moreover with the development of IT system, the firmware and IT oriented or computer application oriented, computer software oriented solutions are also being embedded in this. So, what we will discuss, since we will be having so many different areas as I have just named quickly, mechanical, electrical, control, computer applications or computer software. So, it means that several different specialisms are working together simultaneously, concurrently, because it has to work concurrently, otherwise sequentially if we do, then it is a never ending process kind of a thing. So, in a concurrent engineering condition, therefore, if we are working, so we have to understand that perspective also, how different specialisms are working together and how to therefore manage to mitigate this complexity oriented situation when we are encountering during our design and development activities. All right. So, with this short preamble, I will go into the content slide, which you can see I do not have to repeat, but then broadly it is as I have already mentioned, it is about product complexity in multidisciplinary mechatronic designs. So, naturally it is integration of various specialisms. So, integrative product development will be discussed. And naturally, since we are discussing in terms of since we are particularly focusing on complexity and multidisciplinarity is bringing that complexity more into the thing, and therefore we need to understand the systems elements, that is mechatronic systems elements, which we will also discuss. Maybe it was a part of your course, maybe you have studied it already, but then what we thought is that if you did not have it part of your course, or for a quick understanding, we will go through that once again, maybe briefly, but then we will touch upon those. If needed, you can of course go in the further depth of individual elements and those discussions. So, here what we will do, as we say, the concurrent engineering is one of the important pillars in this, but here we would introduce another concept called set based engineering. This set based concept we will discuss here, we will see that in detail, and therefore what we will do is we will set based means basically we are thinking of developing in multiple sets of solutions in individual or separate specialisms or disciplines, and then not immediately, at a subsequent or later stage we will try and see how those things best fit in, because that means we are trying to keep this design flexible, so that we can evolve a much better system when we are optimizing a little later, and not to start with that immediately we are fixing all the parameters and we are trying to optimize. No, we are trying even to see which set of solutions are the best set, and then we will try and adopt those designs. So, that is the thing. and thereafter we will talk about how PDM, that is the product data management, which is a very interesting electronic assistance through software, etc. The different packages and platforms are available. Through this, we can get the facilitation for concurrent engineering. And we know that, perhaps we know that, maybe many of you know that PDM, that product data management, is a part of the overall system. That is, it is not only design and development part, but then also its use, how it would be manufactured and how it would be then disposed. All these subsequent phases also will be part of it, including its maintenance. So that will be the entire product life cycle, or PLM. So this is the broad or gamut of today's discussion. So we will, since we have in the introduction made it a bit elaborate, we will not perhaps spend much time when the individual slides will be coming up. Then we would touch on those subjects, and we can refer to this discussion that we have had just now in the beginning. So we go to the aspect that we were just mentioning, that now be it a consumer durable product, like say air conditioner or refrigerator or even fans, or it may be an industrial product. It is becoming more and more complex, and is more and more mechatronic, composed with mechatronic elements. Modern products such as mechatronic devices are multidisciplinary, as we have said, and this actually raises the complexity. Now, examples are plenty, and modern product systems such as, conventional cars. We had seen that conventional cars are turning to hybrid electric vehicle or electric vehicle, where a substantial portion of the components are not mechanical but electronic and control system oriented. So, and also with computerized systems where the embedded or firmwares are being implemented. So, starting from there, we can talk of high-end printers, medical equipment and instruments, and already I have mentioned about many durable items, consumer durable items also. So, this associates all these technologies that we have mentioned. So, now if you just see, for example, in the consumer durable, I have already given the example, but you can study it later. I mean, you can get more details, starting from microwave, camera to washing machine, toaster, and air conditioner, I have said. In the medical, diagnostic and test equipment, pacemaker, assisted surgery. In automotive, I have already mentioned about this, but then particularly if we go to the control area, say cruise control, safety airbags, engine management, which is called EMS, engine management system, power transmission, anti-lock brake, etc. So these are examples of this mechatronic system in the automotive sector. In defense, unmanned vehicle is very common. You have seen in many situations, maybe during your course and studies, this unmanned vehicles both for the ground, underwater, air, and besides the regular things, say for example aircraft engines and controls, etc. are there always. In the manufacturing also we see the robotics, CNC machines, automated guided vehicles, inflexible manufacturing systems, that which carries the pallets from the workstation to workstation, etc. Those are all the examples of the mechatronic system. Now you understand it is practically everywhere, and therefore we cannot escape the discussion on the complexity on design and development or product engineering in these areas. So how to address this? That is why we have taken up this topic, and that's why we will discuss the concurrent engineering, more specifically set-based concurrent engineering. Having said that, let us understand that application of multidisciplinary complex engineering system, that is Mechatronics. Here we were talking about that. As I have already said, that the increasing incursion of IT in mechanical engineering imparts significant advantages. Sufficient information is coming, knowledge is coming, and that is creating significant advantages and benefits. And the discipline has evolved due to such a need and termed as Mechatronics, which can be typecast between two major continuums. One is the special consideration. Special consideration means space-wise how it will be arranged within the system, that special integration of mechanics and electronics, such as MIT, molded interconnect devices, like say the communication antenna within the switches, or say within certain electronic devices. Those are the molded interconnect devices that we see. Similarly, there is another part in that continuum, other extreme in that continuum is that which is the control part, that control guided movement of multi-body systems. So, this control part and the special arrangement part, these two actually are the two physical engineering challenges. The particular mix or combination of these two in varying proportions, of course, somewhere it is more, that is less, etc., otherwise vice versa, in a product system is considered depending on the application and the associated design factors. Now, as I said, that since there are multiple disciplines involved, so automatically and naturally what comes in is the integrative product development consideration, and that brings multidisciplinary complexity. So, engagement of interdisciplinary specialisms and experts is a complex task itself. Complex in many ways, understanding the technology, understanding the nuances of technology and their interfaces, the communication, technical communication issues, and the preference of one technology over the other when the optimality comes in. So, all these makes this system, makes this consideration very complex. Continual and effective interaction and sharing between designers and developers, therefore, from different domains during the entire product design and producing new manufacturing technologies is necessary because of this requirement. Particularly when there are weighty interdependencies. Obviously, now practically interdependencies are everywhere. When the interdependence is more strong or more weighty, then it is required even more. All right. So, for the best outcome, therefore, what we need to do, as we said, the product concept determined during the early stage of the development is guided by the manufacturing technologies and systems. So, when we are designing, we are also considering how it will be manufactured, and so all the processes are being considered together. So, design is not completely independent of the manufacturing system or manufacturing processes per se. So, these two are to be taken together in an integrative way, and therefore, this when we are doing these two things or multiple things in integrative way, now different specialism and different kind of spatial arrangement and different kind of control requirement, and that too when we are going for the fabrication of that, with keeping those constraints in mind, be it cost, be it weight, be it volume, it naturally needs a huge integration and collaboration, where the concurrent engineering comes in, so that the smooth operation all these functions together happens. Like say, if one is changing a specification on data or feature somewhere in, say, the electronic specialism, the same thing how it is going to affect the mechanical system, or vice versa. If the mechanical system is changing, how it is going to accommodate that part, electronic part of circuit in that say package, it is of major consideration. Now, naturally, when these two or multiple things are to be taken together, it needs a smooth operational necessity, and therefore concurrent engineering comes in a big way. And obviously, that is very, very important for multidisciplinary complex products. Here we see the importance of concurrent engineering can be more understood from the complexity between individual and collective. Say this diagram presents four broad areas, say mechanics, electronics, firmware and control system. You can see under each what are the general things. Under mechanical comes mechanism, hydraulic, pneumatic, thermal, magnetic and all. Similarly, under electronics you find the analog, digital and mixed signal circuitry. In the firmware or embedded system or computer embedded control system is a computer take. The codes are also written, and the control system that we know is the for the through the transfer function that happens. So now all these are to be done simultaneously and at this intersection of all four. Sometimes maybe other considerations also partly comes in, sometimes majorly comes in, that is also some material science based consideration, material based consideration. Now, so but at the core what you find this is mechatronics. So when all these features are taken together, satisfying the specialisms, requirement of specialisms, and bringing out that device of the product which performs, which actually fulfills or meets the need of the customer, is the objective. And so here the understanding of complexity is a bit clearer, and basic elements of mechatronic system as we know and see here also, the actuator and sensors, signals and controlling, digital logic system, firmware and data acquisition system, and finally the computation and display devices. So we have to see how it is showing, working, etc. So what is the outcome? So that is being displayed. If a temperature is going up, how we are saying digitally. So when you see, say when you use your vernier in the lab, say for example a micrometer in the lab. Now when you see this digital vernier or digital micrometer, what do you see? That this connection between the mechanical movement and its conversion through the electronic system to the display, where we see that okay, this is the movement and that is getting reflected digitally. So the analog signal is getting converted to digital. Now sometimes the analog is, sometimes the signal is the physical signal, sometimes is the electrical signal. We will talk about that, but then let us go to the next slide where we would find those, that these different signals. But here one thing I would like to tell you, how the mechatronic system works. What has been intended here in this discourse is, it has been done very comprehensively, that in fact through one diagram, bringing the whole thing without missing any single aspect is a rather very uncommon or rare, I would say. So we attempted to bring in one screen the whole thing of a mechatronic system, that you can see that basically it has the mechanical system, the electrical system, the controller and the display. Basically, if you see, so here what we see is that on the mechanical system, there you can see that the actuators and drivers, it may be solenoid, it may be hydraulic, pneumatic system, it may be servo motors, stepper motors, or even DC motors, and that actually feeds to the sensor, but feeding to the sensor actually comes through the mechanism which actually it operates through certain displacement that it makes. So, that mechanism changes and that is sensed by the appropriate sensing system. If it is a displacement we are going to measure, then we are taking say potentiometer. If we are taking say proximity, then photoelectric sensor we are using. If we are taking force or pressure, then we are taking strain gauge. So, for say vibration or instantaneous acceleration, we are taking accelerometers. Or position count, so we take the digital encoder, so on and so forth. So, different types of sensors are available for different functional purposes. So, we understand, so there are actuators, mechanism, sensors. That sensor is producing the electrical signal that is going to the system, and through the the system of discrete circuit, filters, amplifiers, this analog is getting converted to digital, and then this digital control architecture, all control architecture comes in the interplay. This microcontroller, microprocessor, PLCs, that is programmable logic controllers. So, all these are there to do the control part of the activity, and that gives it as output signal this signal conditioning and interfacing, that is now we are getting digital to analog for the controlling the actuator which originated, and where in this process what is happening, that the error is getting by the the cyclic operations, as we have explained, the error is getting reduced from these corrections. And so, again, so this process is repeated, and so the correct value is set finally, closer value is, target value is set. And on the leftmost side you can see that the display part comes in, as I said, that in the case of micrometer vernier, or in case of your air conditioner where you can see with your remote what temperature it is, etc. So, similarly here you can see that what is the display. Display may be LED or LCD. Earlier very commonly the CRT, the cathode ray tube were used, but nowadays mostly LED and LCD thing. So, here as it is explained also, sensors are connected to mechanisms. I have already explained that to convert the output signals, that is the variables, and it is sent to the electronic device for amplification. So, from electronic device, the signal is sent to an actuator with reduced error. That is the most important thing, and that is how we are bringing the through the control system to the target values or specifications. So, this is what is being done for the car, this is being done for the washing machine, this is done for the air conditioner, this is done for the vernier, this is done for many or most, even say watches. When earlier all the watches used to be that with the winding system and all, but only mechanical springs, but now it is all electronic, mechanical and electronic combination. So, the life of mechanical engineering today is this, that it has to have the interfaces. So, that is why we are discussing, particularly because when we are talking about design, these are the products, and therefore, the product design angle is to be well understood from this perspective. Now once we are done with that part, we would go to, as promised, we will go to the set based understanding of set based designs. What is it? As I have already explained, that set based are those that individual specialisms are creating different sets to be finally assessed, combining different possible sets for optimal performance. So, this was actually done in the Toyota company to start with. I mean, this was a part of their lean processes, one of the lean processes, lean design process you may say. So, that is where. So, that is where the set based design differs from the traditional approaches. I have already discussed about the PDM, Product Data Management, Lifecycle Management, and also Product Manufacturing Management, where we see that a CAM thing comes in, Computer Aided Manufacturing, but here our focus mostly will be on the design development part. So, yeah, CAM also is important, and their PMM comes in when we are talking about the complete manufacturing of the product. Yes. Now, a quick primer on concurrent engineering and set based design very quickly. As I have already explained, I will not have to spend much time on this slide. That means it is not sequential. See, it is being done concurrently. Each specialism is interacting with the other specialism or subgroups rather, specialist subgroups directly. That is the pictorial representation, and what is written here is only that. It has to be in sync, the product design has to be in sync with the entire continuum of the product ideation to launching in the market. So, end to end, that is what I mean. So, everywhere all these functionalities starting from the ideation, conceptualization, prototyping and finally manufacturing, every are connected. So, I would like to first go to the concurrent engineering, what it affects. You can see very quickly, I would go through these two bars at the bottom. One is that the lower bar, I will discuss that first, is the sequential engineering. What you see that the legends are put on the up, that the deep blue is the product definition, green is design, gray is verification, orange is prototype, red is redesign, re-verification, prototype, etc. Then deep gray is test generation, and blue is production, and yellow is test. So, what we find, the total time required in the sequential engineering is this. I mean, pictorially you can understand that. Now, what we are saying, if we practice concurrent engineering, that concurrently if we do many things that we have to do it, revise it, that is say redesign, re-verification, re-prototyping will practically can be done away with. Now, I ask you to see the diagram once again carefully. What you see, that this red portion, which is the part, redesign, all the that means it should pass and go in one go properly, because we are already interacting throughout. It is not that electronic circuit is given, that mechanical specialism saying it cannot be accommodated, or a mechanical part is given, the electronic engineers are saying no, this circuit can be accommodated, or the PCB cannot be accommodated this. So, we are going concurrently. So, the corrections etc. being done in during the process itself and the beginning itself. So, it is saving all the part of the thing, redesign, re-verification and re-prototyping, the entire time saving is happening. Interestingly, you see, while it is happening, the concurrent engineering says that give more emphasis and if necessary give more time for the design part of it and the defining part of it. So, initially if you give more time to the front end, as we had discussed earlier, the rest part will becoming less. This is the beauty of concurrent engineering. We will see that in concurrent engineering, there are point based and sequential based designs. We will talk about that. Point based means say function A, B, C, D, it is going sequential engineering. It is not concurrent, A, B, C, D sequentially. Concurrent engineering, if it is point based, say what happens, design function of the lower one, the design function solution of function A, which is being analyzed and critiquing means commented on its failure possibilities mainly, and or disadvantages, shortcomings or pitfalls mainly, and then it is modified and accordingly and to suit say function B, C, D and whatever subsequent. So, it is point based. Point based means A is being corrected and accordingly B, C, D is getting satisfied. But in set based, as you can see, this figure is a Raudberget's figure which shows that the individual specialisms of different colors, they are having different sets, and through various layers they are being brought in closer together to see how the individual specialisms, the sets in individual specialism are matching, and their intersection is giving us the design set, final design set, which is called set based concurrent engineering or SBCE, or is also called set based design, engineering or design. And so, this initially it is defined a bit broadly and subsequently it is narrowed down. That is what the set based concept is. And we go to the next slide, we will see how the different say function A, B, C, D etc. there. Now, you see of different, these shapes have been imagined to be so that we can understand their intersection the intersection you can see that initially there was an intersection of certain areas, but when we are considering other constraints, all constraints from individual specialism, the area is becoming narrowed down. The narrowed down, you can see the size of the intersection configuration, which is getting narrowed down, where x axis is the time. So, as I said, the final decision on a single set is deferred as far as tolerable to allow, as far as tolerable, and it cannot be endless. Obviously, within given time and resources it is to be completed, but the purpose is that it gives a better design. So, we have already discussed this, we will not repeat this, the examples are given here, that the ATMs, elevators are the examples. In fact, one thing more would like to say here, the advanced systems, I say computer controlled and intelligent electromechanical systems, any such any electromechanical system when it is joined with the computer control system becomes mechatronics. So, modern applications like IoT or artificial intelligence can also be merged with this in the mechatronic system. If it is good in electronic but not mechanical or vice versa, it will not work. Now, we would talk about some because after all it is a question of career. If you want to build your career in mechatronics, so what kind of skill set you would require. So, here are certain list of software that you can see that in different domains. One thing I will tell you, so in CAD software you have say SolidWorks, CATIA and all, simulation software ANSYS, MATLAB and various others. In program languages C, C++, Python and Arduino, Admiral Studio and those are there. In fluidism, multism and fluidism both will satisfy the requirement of pneumatic, hydraulic and electronic, basic sensors and controllers. And for mechanical modeling, mechatronic modeling, you have say Modelica, or there is an open source open Modelica, or some things like KiCad etc., Octave etc., and also Enovia is there. One thing, do not get scared with this big list, so called big list, many of you already know. Thing is that the entry level mechatronic engineer is not expected to know everything. Therefore, I have written it in this orange color. If you see, the entry level design engineer will not know many of these and will pick up the necessary ones with the time as per project needs. But then some basic things will be definitely be known to him, he should learn. And so, we will come back to the last part of this thing, that is PDM. We have already discussed that the PDM is actually a platform, etc. We will talk about again that that is a electronic data management system. We will give certain reference of the software or platform available for this. Product data management is the technology and supporting software as well as centralized database system that aids the effective implementation of concurrent engineering. That is the in nutshell whatever it has to say. And PDM is within PLM. Now, here as we see that that there is particularly this slide is as I have already discussed on the left side, but on right side I just would like to tell you a good news that there is a learning resource, free learning resource, ANSI student download link which has been provided here, that gives a huge inputs, the mechanical structure to CFD, LS Diana, SCADE, which integrates model based design, simulation, code generation, etc. So, this is, if you see, will be immensely helpful. So, I suggest you go to that site, download some of the softwares, try it, and what you already know, that is I believe well, and with that you can keep on adding things. Now, because those are the things in any case you will be learning on the way. I actually have touched upon these things, name the software, at least you should know where to get and for what. So, we have covered this mechatronic issues, the complexity issues, we have covered the set based concurrent engineering for reasons, and finally, how the concurrent engineering will happen effectively. For that, we have talked about the PDM system, and this PDM system that a name I have already mentioned, that this Innovia PLM platform, Siemens PLM suite, and Adept PDM software, these are certain available things, and so you can always refer to them. So, in the reference you can see it is the reference is given, and I am sure that this gives you an idea as to for multidisciplinary complex system how to approach and how to find the skills required to do this and how to learn it, because certain references are also provided. Hope it will make you a great designer. Thank you very much.